Welcome to this short presentation on driver-based planning in manufacturing. The purpose of this presentation is to create an understanding about driver-based planning within the manufacturing sector. It will present different types of driver-based planning that comprise a manufacturing-specific maturity model. In so doing, it will explain why supply chains make driver-based planning more complex than other sectors, and why complex manufacturers require more mature driver models to achieve their objectives. As you're watching, please remember that the focus of this presentation is on creating an appreciation for the issues, and not to provide a detailed understanding of them. So, what is driver-based planning? Well, it's a method for developing financial plans that are based on models of underlying business activity. The idea behind driver-based planning is straightforward: to use models to quickly quantify the impact of external and internal changes on financials and related risks. So by making changes in one area, the impact can quickly ripple through the financials. These concepts are key enablers of rolling forecasts, a management approach that is receiving increasing attention in recent years. There are three key benefits to driver-based planning. It can significantly reduce planning cycle time, thereby enabling organizations to be more agile. They also enable more operationally realistic plans and forecasts. And these models can also be used to drive scenario planning in order to identify risk. Let's look at an example of driver-based planning. Most driver-based models use some sort of variation of a unit times rate approach. For example, if a hotel were planning on the cost of cleaning rooms, they might use the financial example. Here, the number of rooms is multiplied by an estimated cost per room. If they wanted to use a more operational approach that forecasts a headcount, they might use the second one. In this case, the number of rooms would be multiplied by the time per room and the hourly cost of cleaning. Applying this same idea to the cost of sales in a manufacturer might result in something like what is shown on the screen. In the financial example, the number of units sold would be multiplied by the standard unit cost, which might come from a standard costing system. A more operational approach might quantify both the labor and material cost. What's of note here is that the manufacturing approach is more complex than the service-oriented business. And second, these drivers are typically derived from some separate operational and/or costing systems. More liberal definitions of driver-based planning might include the use of percentages. In this case, the cost of sales are calculated as a percentage of sales. Now, this is the most basic form of driver-based planning model, and it's been used for decades. Since it doesn't really include operational volumes, it's really a stretch to call this a driver-based approach. In smaller and less complex manufacturers, the driver-based planning approaches that we just described typically work well, and manufacturers tend to fully realize the benefits of driver-based planning. However, for manufacturers exhibiting the complexity characteristics shown on the screen, this isn't always the case. Greater complexity makes it increasingly difficult to develop and maintain models that can support forward-looking planning activities such as forecasting, scenario planning, and what-if analysis. The problem being that the models are too simplistic to support effective processes. Provided on the screen is the outline of a four-stage maturity model for driver-based planning. What differentiates the four stages is the degree of financial and operational integration. The black arrow represents the first stage that we just described. As manufacturers become more complex, these simple driver models tend to have three important limitations. First, they take significant time to maintain. Financial analysts are often charged with the task of monitoring changes and reflecting them in the models. And this typically is a manual process that often involves spreadsheets. Second, the results of these models must be reconciled to operations as well as annual business plans, which again can take a lot of time. And third, they often produce inaccurate and/or incomplete results, either because it isn't possible to reflect complexities in these models, or because there isn't sufficient time and/or resources to maintain the models. The net result of all this is that these simplistic driver models are not a leading practice in more complex manufacturers. In fact, experiences from using these types of models have led some to abandon or scale back rolling forecast efforts. The remainder of the maturity model is shown on the screen. The two financial models on the left are more simplistic, What characterizes them is that the models are maintained by finance. These are the most common of driver-based planning approaches, with the most simplistic one being the most common of all, that being the example we covered earlier. What differentiates the two integrated models on the right is that they are shared between finance and operations. Moreover, because they are used by operations to run the business, they are also more accurate, not just because they are more detailed, but because they respond better to change. So let's examine these maturity levels in more detail. The second stage of maturity is called operational estimation. At this stage, finance functions build models that attempt to emulate operational planning logic. They may include things like bills of materials, routings, and standard costs. But they typically lack more advanced logic such as inventory parameters, lead times, and MRP netting. One of the main reasons for this is that such logic is very difficult and expensive to build. The problem with developing such models is that they can take significant time and effort to build and maintain. Moreover, because they can't simulate production inventory, they are often less accurate for forecasting and scenario planning. And they also require significant reconciliation between financial and operational planning systems and models. At the third stage of maturity, sales and operations planning is integrated with rolling forecast processes. At this point, there is no difference between financial and operational planning processes, and we'll explain this in more detail momentarily. At the fourth stage of maturity, financial and operational planning and forecasting are integrated enterprise-wide. This means that manufacturers are able to quantify resource requirements in non-production areas such as transportation, information technology, customer care, and call centers, and do this across multiple legal entities. At this point, there's no difference between financial planning and forecasting, sales and operations planning, and activity-based planning and costing. In operational circles, this is sometimes referred to as extended sales and operations planning. The last two stages of the maturity model are highlighted on the screen, along with two key attributes of each stage. In the slides that follow, we'll explain these four attributes in more detail and how they support more effective driver-based planning. What differentiates models at this stage is that they comprise the logic of a fully functional MRP system, with one exception, of course, in that they're not generating detailed orders. We won't explain this logic here. It's assumed that the viewer is familiar with these classic manufacturing approaches. What this means is that models are able to accurately simulate production activity and costs. Moreover, because finance is leveraging operational models, the effort to maintain them is significantly lower. This modeling logic has the four features which are shown in the center of the screen. Models can be time-phased, different versions can be maintained, and mass changes can be made to them. These features are essential for maintaining operationally realistic models that can support effective scenario planning and rolling forecast processes. Moreover, maintenance of these models can be distributed across an organization. This means that models can be updated fast while simultaneously maintaining their integrity. One of the byproducts of the embedded and shared modeling logic addressed on the previous screen is that it enables automated variance analysis. This means that the models can automatically isolate things like volume and mix variances that comprise the difference between any combination of budgets, actuals, forecasts, and scenarios. This capability is essential for effective scenario planning and for collapsing cycle time. Moreover, when these models are used to support sales and operations planning processes, financial and operational plans and forecasts are automatically reconciled. In other words, there's no difference between financial and operational plans. The next capability provides the means to plan, forecast, and manage productivity horizontally across functions and entities. To illustrate this, look at the graphic on the right. It depicts the key metrics of an order fulfillment process and how they behave over time. The first thing to note is the ability to forecast cost per order across multiple functions and entities. Underlying this is the ability to forecast the total cost and activity volume of the process and underlying activities. The second thing to point out is the ability to focus people on trade-offs between conflicting objectives. In this case, cost per order, perfect order fulfillment, and days in receivable. In other words, it focuses people on driving value rather than on achieving fixed budgets. The third thing to note is the logic underlying this graph provides the foundation to plan and manage cost to serve and segment profitability. And last, the ability to plan, manage, and forecast at this level provides the basis for shared rewards and decision rights that span functions and entities. Some might look at this and wonder what's really new here. In fact, process management supporters have been talking about this for years. What's new are more advanced driver models and planning systems that can support matrix planning. That being the ability to simultaneously plan both functions and processes, and to always ensure that the two are reconciled, as denoted by the red circle on the bottom right of the left-hand side of the screen. This level of accuracy is what has prevented organizations from adopting more outcome-based management approaches to support their strategies. In fact, the absence of this information means that organizations often focus too heavily on budget attainment and or functionally based metrics. And at this stage, activity-based planning is fully integrated into a driver-based planning model. Underlying the graph on the right is the ability to plan work, as illustrated by the graph on the left. The ability to plan work at this level and identify capacity constraints is the cornerstone of sales and operations planning. In this context, sales and operations planning is extended across the enterprise and integrated with activity-based planning and financial planning and forecasting systems. One of the keys to planning and managing this way is the ability to translate trade-offs deep into the organization. To facilitate this, organizations require a business process or outcome-based measurement model that is integrated into planning, forecasting, and measurement processes. This is illustrated by the graphic on the left. One of the key takeaways from this is that more mature driver models also require more mature measurement models, ones that also provide the means to enrich balanced scorecard approaches. In other words, this level of maturity provides the foundation to directly connect balanced scorecard targets with budgets and forecasts. So the last capability that we'll discuss is portfolio management, and this entails the ability to plan and manage the value of product, customer, process, and vendor portfolios. And what's common to all these is the need to plan and manage the cash value of these portfolios across functions and entities. Now, a classic example of this, and a significant challenge for many, is the ability to plan and manage the value realized from strategic sourcing efforts. And this is really just a fancy name for being able to buy smarter. So the graph on the bottom illustrates the cost of doing business with a specific vendor across different aspects of the value chain. So the idea behind strategic sourcing is to really look at the total cost of doing business with a vendor. So in some cases, it may make more sense to pay more upfront on the invoice for a product from a vendor because it'll cost less to actually do business with the vendor. So certain parts may go through the machine faster, they may require less rework, you may require less inventory, less transportation cost. So by looking across the entire value chain, one can actually decrease costs just by taking a more holistic approach to buying. To get the entire picture to really understand how doing business with a vendor affects value, you really need to understand this on a cash basis. And this is what's reflected in this view of the picture we just showed you on the previous screen. Of course, all this sounds fairly straightforward in theory, but applying this in practice has become very complex for some companies. It becomes very difficult to try and isolate the impact of purchasing strategies when you have significant variations in volume, mix, pricing, all stretched across multiple legal entities. And it's the role of more advanced driver models, such as the ones that we've discussed, that provide the means to automatically isolate these variances so you can measure them, but also be able to forecast these savings. And the ability to forecast savings in this manner is really a feature of a much more sophisticated driver-based planning system, and one which is much more focused on delivering value for enterprises. Underlying the ability to forecast sourcing value are all the advanced driver modeling logic capabilities that we've discussed to this point. But one we haven't is double entry planning. Modeling logic that does two things. It automates cash flow and balance sheet forecasting based on predefined parameters. And second, it distributes ownership of the cash flow forecast so that it can be updated quickly. And one thing is important to note here is that accurate cash flow forecasting is contingent upon the ability to understand the flow of goods across legal entities. And the absence of this capability is one of the key reasons why larger organizations cannot accurately forecast cash flow. And it's also one of the primary reasons why they have limited visibility into foreign currency exposure. So the key point here is that forecasting supply chain activity is inextricably linked to portfolio, cash flow, and foreign currency management. So just to summarize, we've just reviewed 4 key capabilities that comprise more advanced driver-based planning models. Now there are many more detailed capabilities underlying them, but these are really the main ones that drive the vast majority of the value of these more advanced models. And to bring it back one more level, what separates more advanced driver-based planning models is the fact that finance and operations share more advanced modeling logic across a single process and system. And it is this integration that supports step change improvements to the models used by finance and operations to plan and manage the business. Ultimately, the decision on what sort of model you want to use depends on what you want to forecast, and more specifically on what type of scenario planning process that you want. Provided on the screen are types of planning activities that you may want to include in a forecasting or scenario planning process. So the more of these that you want to include and the more complex you are, the more likely it is that you're going to want to use something at a business integration level, because as evidenced by the black dots, those are the models that are much more able to cope with that level of complexity. So in summary, the more complex you are and the more that you want to include in your forecasting process, the more you should be working towards a more integrated model. One of the things that you also need to consider are the objectives that you want to achieve. So the more of these objectives that you want to achieve and the more complex you are, the more that's going to lead you towards a more mature and more sophisticated model. And when organizations don't do this, one of the things that they often find is they have gaps. And what you'll see is that in the middle, the driver-based planning capabilities that organizations may have just don't suit their needs, as evidenced by the white part on the screen there. So the key thing to take away from this is to really focus on what it is you're trying to achieve and then think about the capabilities that you need. So I just want to come back to the objectives that we started off with. So I wanted to give you an understanding about driver-based planning and the different levels of maturity and how they differ, why driver-based planning is different in manufacturers, and some of the key capabilities comprising more mature driver-based planning, and the objectives supported by mature driver-based planning. So hopefully we covered those off for you. So if you have any questions or comments about the contents of this material, please feel free to contact the author with the contact information shown on the screen. Thanks for watching.